What you do with your life? Get your education, boy. Subscribe to A's Online.
Okay, welcome back to A's Online Virtual Classroom. I'm Andrew with another mathematics tip of the day presented by A's Online Tutoring Services. Exam success at your fingertips. So here at A's Online, we are on a mission to help you get your education. So make sure and hit the subscribe button as we continue to bring these mathematics tips of the day on a weekly basis. You're going to want to check out all our previous tips right here on our Get Your Education channel on YouTube. And for anyone preparing for SCA 2021, be sure to check out our playlist of SCA Today videos, which you can find right here on our channel. So as we get into it for today, we want to take a look at today's mathematics tip. So we're going to go to the smartboard, and today we're going to be looking at the commutative law. So within mathematics, there are some principles, some laws that govern all numbers. It doesn't matter what level of math you're studying. And today we're going to look at one of the foundations within these laws, and that's the commutative law, which you could apply to any part of mathematics. So the commutative law says, with addition and multiplication, it does not matter what order the numbers come in, you will get the same answer. Okay, so what do I mean by that? Now, let's get some examples on the board. So when we talk about the word commute has a very straightforward definition in English language, or commutative, which comes from the word commute. And many times you would hear commute being used to describe people who are transported. So people who travel on public transport like maxis, buses, taxis, airplanes, trains, anything like that, they call them commuters. So when we apply that principle to mathematics, we want to take that commuting and apply it to our numbers. So to commute means to move from one place to another. When something moves, it doesn't change. That's very important. The number itself stays just as it was in the previous position. So when we have a question like, for example, very simply, we could say we have 3 plus 2. So be a nice simple way to see it clearly. We get 5. But what about if we have 2 plus 3? According to the law, we should get the same answer, which is 5, right? It works for addition, and addition applies to positive and negative integers. It doesn't only apply when you're seeing plus signs. So for those of us preparing for secondary school mathematics, we working with positive and negative numbers. So for example, if it is we have something like negative 2 plus 3, you get positive 1 as our answer. But when we're changing around the numbers, we're not changing the number. So we can do 3 plus, we add in negative 2. And the answer would still give us positive 1. So the commutative law could be applied for any integers, positive or negative. Once, just like how you saw here, we moved the negative 2 to the second position, so we kept it as a negative 2. And if you want to double check me on the calculators, you can. You will get positive 1 for your answers. And it works for multiplication as well. So you could just look at that quickly. If we do 3 times 2, you get 6. Or if we do 2 times 3, you still get 6. So this is what the commutative law allows us to do. And why would we do it? Sometimes when you change the numbers around, it becomes a lot easier to add. So for example, let's say we have a number like 23, or numbers like 23 plus 8 plus 17. We can change that around. We can say 23 plus 17 plus 8. And we will get the same answer. Why I change it around? Because adding 3 and 7 is pretty straightforward. It's 10. So 23 plus 17 will give us 40, plus 8 will give us 48. Some people might find it easier to add like this. I find it easier to add like this. So the more you practice your mathematics, you'll be able to determine what works for you, what is your preference in addition and multiplication. Certain numbers you'll be able to recognize quickly and be able to just apply the laws without thinking twice. Now this law does not apply to division. The commutative law does not work for division. So if it is, we want to get an example of that. We can look at 10 divided by 5, and 10 divided by 5 will give us 2. But if we choose the commutative law and change it around, 5 divided by 10 wouldn't give us 2, it will give us 1 over 2 or 0.5. So the commutative law does not work for division. I'll repeat that again. The commutative law does not work for division, and anytime you have to divide, you have to be careful, because if you mix up the numbers in its positions, you will get the wrong answer. So take your time when you're dividing. Make sure you have the question from the test paper, from your book, whatever exercise you're doing. Make sure you have the question correct and divide accordingly. So that's it. That's our commutative law. Of course, we have other laws to look at, which we can look at next week and the week after. Yeah, that's it. With addition and multiplication, it does not matter what order the numbers come in, you'll get the same answer. Alright, so that is our mathematics tip of the day. Thanks for watching the entire thing. I hope that you continue to get your education as we bring these videos for you on a weekly basis. So yeah, that's it. Make sure and hit subscribe as we continue to grow our Get Your Education channel, helping you prepare for all your upcoming exams. So my name is Andre. It's a pleasure to bring these tips to you on a weekly basis, and I am going to see you next week.
What you do with your life? Get your education, boy. Subscribe to A's Online. Click. We got tutors, they go live. When you're home, you're safe and sound. Subscribe. Just log on, study now. Subscribe to A's Online. Tutors, they go live. When you're home, you're safe and sound. Log on, study now. Subscribe to A's Online. Tutors, they go live. You can log in from your house. I say log in with your mouse. Log on, study now. Subscribe to A's Online. Yeah. Tutors, they go live. You can log in from your house. I say log in with your mouse.